We're going to take a look at difference of two functions. Let's consider an example, and we're going to look at it from an algebraic and graphical perspective. So we're going to define f of x as x, and g of x is equal to the root of x plus 1. So we're going to create the equation of h of x is equal to g of x minus f. Now, order does matter because we are subtracting. Just like 7 minus 1 is different than 1 minus 7. In functions, the order of subtractions does matter. So here we are. So to create the equation, now h of x is equal to g minus f of x. And we can rewrite this as the g of x minus the f of x. The g of x function is defined by the expression x plus 1. And we need to subtract f of x, and that is just simply x. Keep in mind that it's the expression on the right-hand side that I'm using. So when x is equal, I've constructed this table hopefully well. Let's see how well. F of x is equal to negative 1. G of x, f of negative 1 is negative 1. F of 0 is 0. F of 3 is 3. F of 8 is 8, because x defines y. Now, the value of g of x, when g of x is equal to negative 1, if I plug in negative 1 into this formula, what I get is my g of x is equal to 0. So the g of negative 1 is 0. The g of 0 is 1. The g of 3 is 2. The g of 8 is 3. In other words, I sort of just imagined or asked myself, what values of input will lead to integer values of my output? Now, when I'm subtracting h of x, which is just really the g of x minus my f of x, so h of x here is 0 minus negative 1, and that will lead to a value of 1. Similarly, I could do this for the x value of 0, x value of 3, the x value of 8. So given these x values, I've created the y values for my h. And I can go to the graph and graph this if I want. I could use this graph or these points, and they should give me a clear indication. So g minus f. Now, I've, again, chosen my integer values. And if I take a look, f was my linear function, and g is my radical function. So the g minus f. So I'm going to try to do this mental math. The g of negative 1, 0, minus the f of negative 1, 1, is going to give me 1, because 0 minus 1 is 1. Now this is almost hurting my brain. So maybe I should refer back to this table, but I'll do my best. So the g of 0, 1, minus 0 is going to give me 1. Pretty sure this is an unexciting function. The g of 3 is 2. The f of 3 is 3. 2 minus 3 is negative 1. g of 8 is 3. The f of 8 is 8. 3 minus 8 is minus 5. So maybe I should just highlight these points in a dark purple color. So my function might look like this. It will have a bend to it. My domain is defined, where both my functions are defined, and that is going from -1 to infinity, and that's why I have an arrow at the end of my new graph. So again, we can construct the new graph from a table of values, or we can construct working off a new graph. I'll be perfectly frank with you. This is a very complicated function. As a math teacher, I'm sort of scratching my head, how would I graph this? Now, we've entered the sort of prime age of computation and mathematics. Anything that's really complicated in terms of a function, please use technology to graph. I think that should be an expectation going forward. This is pre-technology, these lessons. Things are going to change very quickly. So I have here h of x, just like I've done for the addition of functions. You can look at it, h of x, as you're just combining the y values. And if you're doing f minus g, you would take your point x, yf, and take another point x, yg for the f function, g function, and the x values stay the same, but you subtract them. Order matters. So again, it's only appropriate to subtract two functions in the places where f and g are defined.